All right. As we start into our new unit, we're going to be examining a new type of function that we haven't really looked at in past classes. So that's going to be called a quadratic function. Um, so our targets for today, we're going to work on graphing a quadratic function, as well as identifying all the key features of a quadratic function, and those are all going to be steps within graphing. So those include the max or minimum, the axis of symmetry, the vertex, and the intercepts of a quadratic function. Um, this is one of those lessons where we do need a note sheet in front of us. Unfortunately, our Unit 2 textbook doesn't really have much in form of guided notes to introduce quadratic functions. So at this point, you should get this notes packet from our Google Classroom to take down notes over all of these introductory terms. Okay, so get this accessible. So the topper is going to do a lot of definitions first. So a quadratic function, that's a function that can be written in the form f of x equals ax squared plus bx plus c, where x is the variable, a, b, and c are constants. Remember, constants are just numbers. And the key one is that a cannot be 0. Because if we think about it, if a was 0, then 0 times x squared, that first term really wouldn't be there. We'd be left with just bx plus c, which would then be a linear function, which we've examined in previous classes. Quadratic function, the key piece of this is that the highest exponent in our function is a 2. Okay. An example of a quadratic function that we can write off to the right. We're going to practice using this function notation, f of x. Okay, so f of x equals 1x squared minus 6x plus 8. That would be an example of a quadratic function. Okay. A, B, and C are the numbers in front of each of the variables x, as well as c, that's the number at the end. So if we were just identifying A, B, and C within this function, A would be 1, B would be negative 6, and C would be 8. Okay. Intercepts. Intercepts are things we've seen in previous classes, especially with linear functions. Remember that an intercept is a point that is crossing either the x or the y axis. Okay, there are x-intercepts and y-intercepts. Okay, so an x-intercept is a point of which the function intersects the x-axis. So if we have a quadratic function, the general shape of a quadratic function is a U. Okay, so it could look opening upwards like this or an upside down U. Okay, so in terms of what our options are, in terms of the x-intercepts, we really have 3 different cases. Okay, so I'm going to make 3 little xy planes over here. So the first case would be that our U crosses the x-axis twice, 2 separate times. Okay, so the x-axis, remember, that's the one going left and right. So here we'd have 2 different x-intercepts. An x-intercept, that's always some number, comma 0. So for example, maybe these points are at 2, comma 0, and maybe this one is 4, comma 0. Okay, so that's our first possibility, where we have 2 x-intercepts. Our second possibility, well, what if that U crossed right at the axis? It's a little bit tougher to draw, something like that. Now we only have 1 x-intercept. I don't know, maybe this point is 3, comma 0. Right now I'm just drawing out our different examples or different possibilities. So we could have 2 x-intercepts as we had in the first picture. We could have 1 x-intercept where it only crossed once. Or our third option, it could never cross, where there's no x-intercepts. Okay, so here I'm just going to write none. Okay, so a quadratic function can have a max of 2 x-intercepts, or it could have none. So it could have 0 x-intercepts, 1 x-intercept, or 2. Okay. A y-intercept, well, that's a point where we're crossing the y-axis. Okay, so that's always going to be 0, comma, some number. Okay, so for example, if I drew out another xy plane, maybe my quadratic function looks something like this. Okay, well, the y-intercept would be the point where we're crossing this up and down y-axis. So maybe this one's at 0, 8. Okay, then your y-intercept would be 0, 8. Again, before we get into graphing, what we're doing right now is we're introducing all these different vocab terms which make up the key features of a quadratic function. All right. Next, we have the axis of symmetry. Okay, so a quadratic function is always symmetric about a line that goes up and down. Okay, so if I drew we call quadratic a parabola. Okay, it's a fancy word for that U-shaped figure. There's an axis of symmetry that's going straight up and down, and you'll see it drawn in often with a dashed line. Okay, and that's whether our parabola is opening upwards or if it's opening downwards. We still have that axis of symmetry. Remember, the word symmetry means that the left side and the right side of that line are equidistant from that line, where it looks like a mirror image. Okay. The axis of symmetry, we have a special formula when we're in what we call standard form, which is what we saw at the top here, f of x equals ax squared plus bx plus c. There's a special formula we use to find the axis of symmetry. It's x equals opposite of b over 2a. And remember, that's referring to those values a, b, and c in the quadratic that we were talking about. So an example of an axis of symmetry, the x equals any number. Okay. If you think about why it's x equals, if you're thinking about graphing a line that was x equals some number, that would be that vertical line that we're drawing in. Okay. Next, we have maxes and mins. Okay, so a maximum, that's the largest y value of a quadratic equation. Okay, so this is just going to be some number. And same thing with a min. It's just a number. We're drawing a sketch that showed what would look like when we would have a max value. That's going to be when it's an upside down parabola. Okay, because then we have a highest point, a max. Okay, so this would be our max right here. So what we're going to notice is there's a key characteristic that makes these parabolas open downwards, and that's that value in front, a, being negative. Okay, when a, the number in front of the whole quadratic, is negative, our parabola, our u, opens downwards. Versus a minimum, well, that's when we have something like this, where it opens upwards. Now we have a lowest value, a minimum. We're going to notice that the key characteristic that makes a quadratic open upwards is that the a value in front is positive. Okay. So when a is negative, it opens downwards and we have a max. When a is positive, it opens upwards and we have a minimum, a lowest value. That max or min, the point at which we are looking at, the ordered pair, right, some number, comma, some number, that's the vertex. Okay, that's a very important vocab word with a quadratic. The vertex is that point that is either our max or our min. Okay, so going back to those little sketches we just drew, for opening upwards like this, our vertex would be this point right here. Okay, or if we were opening downwards, something like this, the vertex would be this highest point here. Vertex. Okay. Sorry, the handwriting comes out there. That's the vertex. Okay. So from here, we're going to start working on graphing quadratics and getting used to all of these different key features, these key vocab words. So we're going to start with the simplest quadratic possible, which is just f of x equals x squared. Okay, so we have f of x equals x squared. And we're going to work on graphing that. Okay, so if we were going to write out our function with our values of a, b, and c in there, what we'd really have is f of x equals, well, there really is a number in front of this x squared. It's just a 1. So this is really saying 1x squared. And then remember there's that plus bx plus c from above, right at the top. Our general standard form was f of x equals ax squared plus bx plus c. So if there's no numbers written there, really our values for b and c would just be 0. Plus 0 times x plus 0. Okay. That's really what we have here. Okay, so if we think about the vocab we had above, in terms of whether we have a max or a min, well, the number in front of x squared is really a 1, which is positive. Okay, so in terms of our max versus our min, a, the number in front, is, a is a positive number. That means our general shape is it's going to open upwards like this. Okay, if that's the case, and we're thinking about do we have a max versus a min, well, we have a lowest value, a minimum. Okay. The axis of symmetry. We have a special formula from above. I'm going to rewrite it down here. X equals opposite of b over 2a. Okay, x equals the opposite of b over 2a. Well, let's just substitute in our values for b and a. So b, that's just 0. So really we have opposite of 0 over 2 times a. Well, a is 1. Well, this is really saying 0 over 2. That's just 0. So our axis of symmetry, x equals 0. We're going to work on graphing this. So our first step in graphing our quadratic is going to be to draw in our axis of symmetry. Here our axis of symmetry is x equals 0. Remember, this is going to be the vertical dashed line by which our parabola, or u, is going to be symmetric on both sides. So if it's x equals 0, I'm going to draw in a dashed line where x is 0. Well, the x's are going left and right. So x being 0 is right here at the origin. Now, I'm going to draw in a dashed line from here, going up and down. Okay, that's our axis of symmetry. Okay, so first step we did was we drew in our axis of symmetry. The vertex. Okay, so the vertex is always going to be our axis of symmetry as our x, comma, f of our axis of symmetry. Okay. So we just said our axis of symmetry was at x equals 0. So now to find the y that goes with that, we're going to plug in our x value in and see what we get. Okay, so we want to find what is f of 0. Plugging in 0 for x. That's 0 squared. So f of 0 equals 0. Well, that would mean our vertex is occurring at 0, 0. Let's plot that point. So your vertex is always going to be on that vertical line somewhere. Okay, so here we got 0, 0. Next, it says plot 4 additional points. Well, from here, we're going to just substitute in easy x values and see what we get in our original function. For example, I could find f of 1, plugging in 1 for x, well, that's 1 squared. So f of 1 equals 1. So I'd have the point 1, comma 1. I could do the same thing with 2. F of 2 equals 2 squared. Well, 2 squared, that's 4. So I have the point 2, comma 4. 1, 2, 3, 4. From here, if I wanted to get some more points, what I could very easily do now is use this axis of symmetry to help us out. Okay, so my axis of symmetry is right here. I could reflect over my points. So if I went 1 to the right here, it's going to be symmetric on the other side, and I could just go 1 to the left. I could do the same thing for this point up here. I went 2 to the right, so I could go 2 to the left. Well, now hopefully we're seeing that U shape is being created. Now I could sketch in my U. It looks something like this. Something like this. Okay. So our goal for today is going to be to practice getting all of these different key features of a quadratic and use that to graph it. Okay. So let's keep trying some more. We flip the page. Okay, so example 1. So this one we're not going to graph from scratch, okay, but it's giving us the graph and we're practicing seeing all the different values. Okay, so from here, it gave us the graph. Notice our function is a little more complicated, right? We have more values in here. So if we were just thinking about what A, B, and C are, A, well, there's really a 1 in front of that x squared. B, well, it's negative 4. And C, negative 5. Okay. So first, do we have a max or a minimum? We could actually figure that out without even looking at the graph off to the right. In this case, A is positive because it's 1. So A is positive. So we knew without even seeing the graph it was going to open up like this. This means we have a lowest value. So we have a minimum. Okay. We could actually look at the graph and see what the minimum is. Well, the minimum would be the lowest y value. Well, we see that down here with this point, 2, negative 9. So the minimum, the lowest value, would be negative 9. Okay. Next, we have the axis of symmetry. Okay, so we could actually calculate that. We can also see it on our graph. So we have x equals opposite of b over 2a. Well, the opposite of b is negative 4, so that becomes positive 4 over 2 times a, that's 1. 4 over 2, so 2. Okay, so our axis of symmetry is x equals 2. Well, we see that on our graph also, right? It's drawn in right here in green, going up and down. Our vertex, that's where we plug in our x value of 2 and see what we get for our y. So y equals 2 squared minus 4 times 2 minus 5. So that'd be 4 minus 8 minus 5. Well, 4 minus 8 minus 5, that's negative 9. So our vertex would be the x value, 2, comma, the y value, negative 9. Well, we see this on our graph, 2, negative 9. The y-intercept, well, that's the value of y when x is 0. Okay, so we're going to plug in 0 for x and see what we get for y. If y equals 0 squared minus 4 times 0 minus 5. Well, these cancel, so we're left with just negative 5. For y-intercept, 0, negative 5. Well, we see that on our graph right here as well, right? We're crossing the y-axis at negative 5. So it's the point 0, negative 5. X-intercepts, we see that on our graph as well. Okay, so our x-intercepts are at negative 1, comma 0 and 5, comma 0. Later on, we're going to go over how to find those separate from just looking at a graph. Okay, but again, what we're doing today, we're practicing getting all of these key features of our quadratic. Okay, let's put it all together now. Okay, so we're going to identify the key features and then sketch the graph. Okay, so we have if we look at our function here, it starts with saying max or min. Hopefully we're seeing a, the number in front, is negative. So if we think about what a sketch of this would look like, it opened downwards. Okay, so in this case, we'd have a highest value. We're going to have a max. First thing we're going to do to graph our quadratic is find our axis of symmetry. Remember, we do opposite of b over 2 times a. So b was negative 12. So opposite of b, positive 12 over 2 times a. A is negative 2. So 12 over negative 4, so we get negative 3. Okay, so we get an axis of symmetry, x equals negative 3. At this point, I'm going to stop and put this on my graph. So x equals negative 3. I go over 1, 2, 3 to the left. Now I'm going to draw in a dashed line. That's our axis of symmetry. Okay. Vertex. Well, the vertex, that's the point that's on this axis of symmetry. So we need to find the y value when x is negative 3. Okay, so I'm going to plug in negative 3 for x. Oh, that's a different color. So f of negative 3 equals negative 2 times negative 3 squared minus 12 times negative 3 minus 10. Okay, a little messier algebra one. If I didn't have a calculator here, remember I'd have to take care of this exponent first. So I'd have negative 2 times, well, negative 3 squared is positive 9. Then negative 12 times negative 3, that would be plus 36 and minus 10. Negative 2 times 9, negative 18, plus 36 minus 10. So I wind up getting 8. Okay, so my point is going to be at negative 3, comma 8. I'm going to plot that point on my graph. So negative 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's our vertex. Y-intercept. Okay, so remember we put in 0 for x, see what we get for y. Okay, so f of 0 equals, I'm getting a different color going, so negative 2 times 0 squared minus 12 times 0 minus 10. Well, the zeros are going to cancel out some pieces in here. That cancels. We're left with negative 10. So y-intercept, 0, negative 10. Let's plot that. We start at 0 and count down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. Okay. Then, at this point, since I just plotted that, I can reflect that point over. Okay, so I count 1, 2, 3 to the right. So I'm going to count 1, 2, 3 to the left. There's my point. Okay. So it says x-intercepts next. I'm going to leave that piece for our next lesson and just give them to us today. And then we'll go over this the next time. So our x-intercepts wind up being at negative 5, comma 0 and negative 1, comma 0. I'm going to plot those. Okay, again, I'll go over how to do that the next lesson. I think that we have a good amount of information we've already covered today, so we can cover that piece next. And now I can draw in my general trend. Okay, so it looks something like this. Okay. All right. If we flip the page from here, we got one more. I put a nice little checklist together of our steps, okay, as a reminder. And then there's one more example at the bottom. So I want you guys to now try to do this one on your own, and then I'm going to display the answer after and we can discuss it. Okay, so try this on your own. All right, let's see how we did. So here's the correct work. So A value was positive, so we would have a minimum here, it would open upwards. Axis of symmetry, opposite of B over 2A. We should have gotten 2 for our axis of symmetry. Okay, so notice that's drawn in on our graph at x equals 2. Our vertex, then we would plug in 2 in for x and see what we get. So that's what we're doing here. We're finding f of 2. So we should have got -2. Okay, so then our vertex is at 2, -2. Our y-intercept, you plug in 0 for x and see what we get. The trend hopefully we're seeing is that when we're in this standard form, our y-intercept is really just the number at the end, because when we plug in 0, each of these terms will cancel. So we get 0, 6 right here. Notice we could reflect that point over at this point. X-intercepts, we'll go over how to do that part tomorrow. Okay, so we should get 1, 0 and 3, 0. And then we can draw in our sketch. Remember, you could find more points on here just by substituting in other x values. Like maybe you plug in, I don't know, -1. Well, you could plug in -1 here, see what we get, and that will give you that point. Okay, so we can find more points than even what we have. Okay, but that's our starting point into graphing quadratics and its key features. Okay, so that's what we're going to start with today.